Okay, so before we start doing transformations, exponential and log graphs. Okay, before we start moving them around, we should probably know what they look like, right? Just in general. So we need a few sets of axes here. This is going to be exponential, and this is going to be logarithmic graphs. Exponential graph, so y equals b to the x. And logarithmic graphs, y equals log base b of x. We're comparing the two, right? Number one, these are inverses of each other. That's the first thing to know. They are inverses of each other. So if you know that one looks like this, its inverse looks like whatever you get when you reflect it over that line, y equals x. If you reflected it over that line, you would get, now don't draw these graphs yet, let's get them on paper first. If I was to draw a reflection of that line, think about where it's going to be. In some respects, on your paper, it's easier if you actually turn it. Now, I can't turn the screen up here, but if you're trying to draw it on paper, turn it up so that that diagonal line is upright, and it's far easier to draw an inverse. So if you're trying to draw the inverse, it's going to look like that, right? That's a reflection, except I didn't do such a great job, but something like that, right? If this is 0, 1, this is 1, 0, right? But we don't want this on this side because I want to draw it on this side, right? There's what a logarithm graph looks like. That's if the base is bigger than 1. This is if b is bigger than 1. This is if b is bigger than 1. Those are inverses of each other. And it's important to realize they continue in both directions. It's important to realize that one has a horizontal asymptote. So then the other one has a vertical asymptote. All right, for the same reason that one of them can't have any numbers, you can't get y values here that are negative. You can put any number in for x that you want for an exponential graph. You can make the power positive 1,000, you can make it 3, you can make it 0.6, you can make it negative 2, you can make it negative 1,000,000, but you can't get negative y values. The range is from here and up. None of this, the graph doesn't exist below the axis. That corresponds over here to the graph doesn't exist on the left side. The reason it doesn't exist on the left side is because the x has the restriction on it here. The domain is restricted for a logarithm function. You can't have negative values, you can't have 0. In this case, x has to be greater than 0. That's the domain. In this case over here, y has to be greater than 0. Right? For an exponential function, the range is restricted. For a logarithm graph, the domain is restricted. So far, so good, I think. I hope. No? We haven't even put any numbers to this. The only number we're going to put right now is to say that that's a 1, right? It crosses at 1. So then the logarithm graph crosses the x-axis at 1. Now we've done graphs where b is bigger than 1. If we look at where b is less than 1 for exponential functions, we've done that, right? If you have instead of this one would be like, y equals 2 to the x, it looks like that. When we changed it to a half to the x, remember how the graph changed, right? Let's go back to this for a second. You've seen this before. If I change the base on this thing, okay, when you have a base that's bigger than 1, right, 1.3, all that, it goes up to the right. If you make the base smaller, it goes down to the right for an exponential graph, up to the right, down to the right. Okay? Yeah, it's exactly like that. This has sort of a positive slope. You haven't really talked about slopes of curves, but anywhere on the curve, it's going up, right? It's got a positive rate of change. It's sloped up. If you make it less than 1 here, it's going down, right? It's sloping down. So you could maybe make that connection in your mind. It isn't positive or negative base. It's bigger than 1, smaller than 1. All right, so let's try and draw that, even though we've probably drawn it before here for exponential, but it doesn't hurt to do it again to try and make the connection with what we know. And now there's that. Let's make some more space here. Hopefully I can fit the whole thing in at once. We'll make another one that's probably big enough. Exponential functions, let's make this one green. Exponential functions where b is less than 1, a number like a half or 0.3 or something like that. We do have to put on here, though, that it's greater than 0. And suddenly when you have a double inequality, I think for some people that looks more confusing. Just realize that all it's saying is it's a number less than 1, but a positive number. It's still going to cross that same point, but it's going to go down to the right, like that. Okay, it's going to go down to the right instead of up to the right. It's a mirror image of this. If I had done it on the same grid as up here, it would look like this. It would be a mirror image of that. If I could draw properly, it would be a mirror image of that. Right? That sort of looks like a mirror image of the other one. These are reflections across that axis. It goes down instead of up. If you want, write it on your page on the same grid or same axes, or put it on a separate one, whatever you want. Okay? This is still a 1. If you had to draw the reflection of that, because this is the one we haven't really looked at yet, a logarithm function where the base is less than 1. This one up here might be y equals log base 2 of x. We haven't looked at what does it look like if the base is less than 1. If the base is less than 1, like for instance, y equals log base 1/2 of x. Think of numbers that are nice powers of 1/2. Now let's go to an actual grid here so that, no, not that. Let's use a grid on higher up on here. So I'm going to skip back here for a second. I'm just going to use this grid even though this is not for this question here. We'll use this grid. Get rid of that. Get rid of that. Okay, if we want log base 1/2 of x, and in fact I've got log base 2 of x there, how are these values going to be different if I change this now to log base 1/2 of x? How's that going to be different? If I put a half there now, what's going to happen? They're sort of going to reverse, right? Now, the fractions are going to be the positive powers of 1/2, right? 1/2 shouldn't be, this value is the easiest one, right? Log base 1/2 of 1/2, what power is that? 1/2 to the 1 is 1/2, right? So this is going to be positive 1. This is going to be positive 2 because a quarter is like 1/2 squared, right? The log base 1/2 of, remember, when you're thinking of logarithms, you're just thinking what power of this base is it? All of these are going to reverse. These ones are going to be the positive ones. These ones are going to be the negative ones down here, right? I got to go 1/2 to the -4 to get 16. 1/2 to the -4 is like 2 to the positive 4. It's going to reverse. Think about what that does on the graph. Instead of having these points like this, because this is what log base 2 looks like, it's going to be all the reverse points here. The y values are going to be opposite. So instead of positive, it's going to be negative. Instead of positive 2, it's going to be -2. Positive 3, -3. These are all going to be down below here. And the ones that were down below are going to be up above here. So the curve is going to look like this. It's going to be a vertical reflection. This one is y equals log base 1/2 of x. And as compared to this one up here was log base 2 of x. It's a vertical reflection. These are vertical reflections of each other. Because the y values are opposite there. The reason those are vertical reflections is because they are the inverse. Each of those is the inverse of an exponential function. And if we go back down here, these two things are horizontal reflections, right? Exponential functions are horizontal reflections. we could even put that in here. These are horizontal reflections of each other, right? Right? The points switch sideways like this. I know it's maybe a bad idea to be writing a vertical arrow here to say horizontal reflections, but that's just the bad way I put the pictures. I should have put the pictures side by side maybe. It'll work for the logarithm ones though. So, okay, those are horizontal reflections of each other. These are going to be vertical reflections. All right? Let's draw the graph of this then over here because we don't have it. So something like the base where the base is less than 1. We need a set of axes here first. Something like this. It's going to be that vertical reflection. So instead of, I'm going to draw it on this one so we can then transfer it. You draw it on the separate axis if you want. Instead, it's going to be this mirror image of it here like that, right? It goes down to the right instead of up to the right. This is sort of the same as the other one here. Now, can I get this graph without getting the other stuff? Move it down below. Okay, I'm going to put it on its own axis here. Something like that, right? Except that's not the same size, but that's okay. Great. Wouldn't it have been faster just to rewrite it? Yes, it would have. Sometimes technology makes things slower. So that's down to the right like that. At this point, I haven't put any numbers on there or anything. The only point we're looking at here is that's a 1. Right? Just like this one up here is a 1, even though my scale is obviously different. Those 4 sort of basic graphs, before you start doing any transformations or anything, it would help to understand those 4 basic graphs. If you know, and make connections between all of them. Make the connections that logarithm graphs are vertical reflections of each other. Okay, base bigger than 1. This and this are vertical reflections. And these are horizontal reflections of each other. If you want to put an example there, example of this is y equals log base 2 of x, right? Base is bigger than 1. An example of this is y equals log base 0.5 or a half of x, right? You put a half or log base 0.5, that's an example of this. Example of this one over here, example y equals a half to the x or 0.5 to the x or something like that, right? And an example of the one up on the top here, the first one we looked at, this is 2 to the x, right? For example. Know those basic graphs. The domain for the logarithm functions is x has to be bigger than 0. The range is restricted for exponential functions. The range is only positive values. Okay? Any questions about that? Lots of information? If you start doing transformations of these, you do exactly what you've done before. Okay? We'll talk about that in a minute or two here.